It's just an orientation class today. It's not like we are going to code something or we are going to talk any algorithms or maths or build anything, nothing like that. So it's going to be a little lightweight and feel free to be interactive. Feel free to ask questions. So I might not be able to answer it instantaneously, but I'll be able to take up all the questions once I have said what I intend to say, the important points. Yeah. So probably let us get started like this. I think many of you are here for the first time, and usually I have seen that people in AI cohorts, they are from diverse backgrounds. So in the first cohort, there were some SDs, and there were some program managers, and then there were some product managers also, and then there was, of course, some college freshers as well. So I believe we might have such sort of audience over here. So it's a great idea to probably talk a bit about yourself. You can just write about yourself and just try to write 2 lines about yourself and mention what is your current role and what is the current industry or organization that you are working in. If for some reason you're not working currently, you can say you are off work right now. If you're a student, you can mention your student and sorry, you can mention your name and college name, your branch, everything. You can also mention your experience level. So just a very brief description about uh, like whatever you would like to talk about yourself in these things. So that will help me understand that how many people here are from software background, how many people here are from non-software background or DevOps or something else. Okay, I can see some people have already started typing in SSE in Microsoft. Okay, that's senior software engineer. Worked in Atlassian and other unicorns before Microsoft. That's amazing. Awesome. Vikas is backend developer with tech stack Java Spring Boot, 2 years experience. Great. Arjun, 4 years experience, Tata AIG. Okay, great. Abhishek works at last mile payments team at Amazon. Oh, I think I even know this team. I think I sometime back when I was at Amazon, I worked with it. If it is in Hyderabad, is it in Hyderabad by any chance? Amit is SD2 at Amazon, 8 years of experience, amazing. Sai Ram is engineering manager at now Floats. Chinmay is finance analyst. Okay, great, at Bajaj Finance Limited. Uh, Shubham is product manager in an e-commerce industry. Ankit SD at Urban Company. Wow, amazing crowd. Ankit is from ITBHU 23. Okay. Probably the junior most, is it? SD1 at Lighthouse, Pune. Prashant is dead at Capgemini. Shivam Sairam is engineering manager at Nowfloat. Yeah. Shivam is SSE at Make My Trip. That's great. Java Spring Boot. A lot of people seem to have experience from Java Spring Boot domain. Okay. Worked in healthcare. Okay, that is what AJ says. I can't read your full name because you have just written the initials of your first name and surname. But that's all right. Vinod is doing masters in ML at University of Arizona. That's amazing. Neha is full stack developer in SaaS with 7 years of experience. That's great. Uh, Shane, uh, I'm not sure I'm pronouncing it right. Shane Goda has 15 years of experience. Oh, I believe the senior most with us. Vidya Chidambaram, Red Hat, 10 plus years experience. Amazing. Ankit Guddewala, I know you already. I think you have learned with us before. You are senior engineer, software engineer too at Microsoft, working on building agents. That's amazing. Yeah. Pratyush currently as senior software engineer. Okay. Pranjal, TRM Labs. Okay, so many engineers here. Subhadeep at Amazon Payments team. I think we had one more person from Amazon Payments team. I think we had Abhishek from Last Mile. He was from Last Mile Amazon Payments, I believe. Yeah. So, uh, okay. Sri Purna says, okay, I I might have missed many of you. So I'm like, because I'm just randomly scrolling through it, but I can see we have huge diversity of people within the software engineering ecosystem itself. Somebody's from fintech. Pralay, I know Pralay. He has been with us before, and he's a principal SD. Was with Amazon for 11 years, and then at Coupang Seattle for 3 years. Oh, that's amazing. I also consult at ThoughtWorks and BCG. That's awesome. Okay, amazing people with stellar backgrounds. And Shubham has 4.5 years experience in Samsung. That's great. 3 years in Oracle, and then currently off work. Okay, great. Anjali, Vikram, hi Sangram. Sangram, yeah, I think I know him as well. Yeah, SMTS at Siemens. Abhinandan, uh, doing his MSCS at University of Buffalo. Sridharan is software engineer at Oracle. Okay, for anyone LLD course. Okay, LLD. Oh, thanks for the mention. I think it took a lot of effort in building that LLD course. Okay, awesome. Great. I mean, like when I was going through it, I found almost everybody to be a software developer. So I think I can fairly assume that everybody is hands-on with at least one programming language, and you guys understand the basics of software engineering. Some of you, if you are not in that bucket, nothing to worry about it. What we will be doing is we will be giving you an access to Python course. So Python will be the language which we will use to code. And do not worry if you're not hands-on with Python, because this course is not, this course is basically at the intersection of software engineering, creativity, and some sort of product management, you can say, domain expertise. So, I mean, to be very honest, even I was not hands-on with Python. I did not write any Python script 1 year back or something. It was only when I was tinkering around with LLMs and trying to build some AI agents, playing around, then I started exploring it and I found it was pretty easy to learn. So you do not have to learn Python the way you learned C++ or Java in your college. You do not have to start from data types and all. You just code along, look at the code, try some feature changes, and then automatically you start getting comfortable with it. Also, another thing that I would like to say is that the way coding is kind of evolving these days is pretty much different than how it traditionally used to be. So 50 to 60% of the code, if you are vibe coding efficiently, is being generated by AI. So how many of you uh, do that? How many of you in your current organization uh, feel that 50 to 60% of the course that you kind of write is being generated by AI? Okay, there are two parts to it. Certain times, when you are into a very niche domain, that might not be the case. But if you are prototyping something, if you are refactoring an existing code base, or writing so much of boilerplate, writing so much of test cases, then I mean, AI is pretty helpful at, helping you generate some initial skeleton, which you then later on refine on your own. So that is how it kind of goes. And I mean, certain people feel that it's going to kill creativity and all that, but there is another way to look at it. The another way to look at it is that probably the kind of projects that you were able to earlier pull off in 1 month, if you have great design clarity and requirements clarity about that project, and you are good at vibe coding, you can probably pull it off in 7 days. And that is a reality. I mean, uh, that can happen, and this is something which could not even be thought of uh, 3 to 4 years ago. So I mean, this is one of the benefits of AI that you can see in these days. Yeah. um all right. Copilot is helping us in refactoring. Yeah, that's what exactly. So refactoring is something which it is very good at, because probably it has been trained extensively on the code bases that have been refactored. I mean, and there are many open source SDKs and code bases like that, whose different versions it might have gone through, and it would have learned that. So I have personally seen, like, if I give it a code written by me and ask it to refactor or make it more generic, I have seen it perform brilliantly on that. Ankit has a question. Are doing Renaissance course in C++, will it be difficult to do all these in parallel? Not really, because these classes happen only on Saturday and Sunday, so you can just fix your Saturday and Sunday for AI engineering and probably revise it once a week, and that should be enough. Yeah. So it's not going to be as grueling and as, I would say, heavy in terms of learning curve as DSA or anything else that you have there. So that should not be a concern, ideally, I believe. All right. Uh, Another thing which I wanted to know from everyone is, in fact, I want everyone to write. This is a very different kind of question, but I really want to ask it, and I really want you guys to write about it. So I talk to software developers from varying backgrounds day in and day out. And one thing that I get to hear from everyone is some sort of a concern, some sort of a scare, or, okay, I don't want to call it like that, but some sort of a fear at the back of their mind. And like whenever they get into a conversation, most of the times it kind of turns out that the very basis of that fear is not correct. Sometimes it is not even existent. Yeah, many times that is real, but it can be worked upon. So I want to know from you guys that what is it something which is kind of like a concern, maybe like a sand particle inside your eye, something like that, a concern, a fear, or something like that behind your head, at the back of your mind. And it has been like that since last some weeks, or since last some months, or since last some years. So if there is anything like that, you can just type it in the chat box, maybe in one line or two line. And let's see that how much of deduplications we get. Let's see how many people have the same kind of concern, same kind of scare behind their head since some amount of time. And then we will try to talk about some of them as the class kind of progresses. Yeah, so feel free to write that. Vidya has written, Cursor and Claude are good at brainstorming, planning, test case generation, debugging. Do I use uh, agent generated code for production? No, it takes time to read the code and validate. Yeah, I totally agree with you. Like, that is where the challenge is, to tune it to write a production grade code is something which requires a lot of design clarity. So you as an SD2 or SD3 have to be very clear about the design, that which APIs I need to write, which layers do I need in my code. And so once you are very clear with these things, and once you draw those lines for it, then it is able to do the job well. But if you give it an open space, so imagine there are some children and you let them enter a garden, they'll create a mess. So it's just like that. But if you create small cabinets inside which they are, and kind of give them exact instructions, then they usually do well. They do great. Yeah. See, if you go through what people have written, most of the people have written AI taking over jobs and people being unemployed, and okay, AI making data quality seamless. Okay, that's a good thing. I'm not able to perform as a software engineer on the same level as my peers. AI agents have increased the expectations. That's a very, very valid point. I'm planning to switch companies, but I'm uncertain whether I should prioritize learning AI or. Okay. So I'm pretty sure that many people over here might at some point of time in last 1 year or so would have had something similar to this in their head. So I'll tell you one thing. Honestly, I also do not know the answer to it, that 4 years down the line, how is software engineering landscape going to look like? I do not know. But if you look back at history, and if you read some blogs written by really, really knowledgeable people, they have mentioned it, that whenever a revolution happened in software engineering, mostly in coding, in programming, then the number of coders, the number of software engineers, it rose, it increased. So imagine, I mean, very initial days when coding was literally done on bare metal. like the disks and tapes and all those things. Even let's talk about the assembly language when coding was done completely at the level of bits and bytes, at the level of language which machine could understand. There were very few programmers because it requires a lot of expertise to understand the machine at the level of machine itself without any abstraction and write assembly level language code. But the moment high level language started coming up, like C came, C++ came, then Java, then Python. As these languages came, the number of software engineers started to grow. So a lot of people, they give this prophecy that what really happened when high level languages came, they made coding easier. When they made coding easier, it now kind of required less amount of expertise to write the same code which so imagine you have to write a bubble sort code in Java versus you have to write a bubble sort code in assembly language. I mean, it's very hard to write in that language, right? So that being the reason, the number of people who became software engineers who learned to program, it kind of grew. And many people, including Andrew Ng, many of you would have heard of Andrew Ng, has said it that most probably with AI, this is the thing which is going to happen. Okay. But then there is no certainty about it because if you look at it from another angle, AI is a complete paradigm shift. It's not like it's just making the task of coding easy. No, it is making the task of problem solving, design, computational thinking, design thinking, product thinking, everything. It is abstracting that out. So initially, I mean, when these technologies and high level languages they were coming up, they were not commoditizing the intelligence. The intelligence was not a commodity. But now intelligence has become commodity to some extent, I would say. And who knows, like, uh, if another breakthrough in the LLM architecture happens, maybe it might completely become a commodity. So in that, the situation is going to be completely different. But whether that is going to happen or not, and how soon that is going to happen, is still a big question mark, which we do not have answers to, right? So my personal take on this is that something which we do not have control over, whether this is going to completely commoditize intelligence or not, should probably not be a cause of concern. I mean, even if it happens, then it happens to the whole world, right? So probably there will be different kind of job roles, and uh, the entire world would function differently. There's like big societal changes, right? But if you look for the upcoming 4 years, 5 years, or I mean, the number of years that it takes for the next breakthrough to happen, then the kind of thing that looks very apparent is that people who will be very, very good with problem solving and at the same time would embrace AI rather than running away from it will be the one who will be making greater progress. Because, like, you have seen, you might have seen it, like, one very normal trend which has started in industries is that managers and leads, they kind of expect that the same SD1 who maybe 4 years ago was able to do just his job, his portion of sprint tasks, should now be able to do the job of maybe two or three different SD1s. And let me tell you, that is not going to happen. That is not going to happen until unless that SD1 uses the traditional ways to code and does not take help of co-pilots and at the same time upskills himself. So there's a multitude of things, but when put in rightly in a balanced manner, I believe that there is still a lot of scope of growth in upcoming 3 4 years for all the software engineers, particularly the ones who are uh, in their early career phase, SD1s and SD2s. That's like my personal take on it. And having said that, what I the last thing I want to tell you is that do not be scared about the things like AI will take away all the jobs. Because if that happens, that is some change which will probably change the whole world. If at all you have to worry about, worry for the next 2 years or 3 years. Worry from the perspective that, okay, like probably you have somebody in your team who you can look up to who's probably gotten very, very efficient. And how can you match the efficiency that he has. So that is an intelligent thing to worry about, according to me. But worrying about something that all the jobs will be taken away, so what to do in that case, is probably, according to me, not such great thing to worry about at this point of time. Yeah. All right. I see a few questions. Do companies still rely on DSA and lead code style questions? Yeah, exactly. They do. They do. So a few days ago, I was talking to somebody uh, who I consider as one of the greatest engineers in India and a very inspiring person. I'll bring him to one of the sessions that we'll have. So he told me that these days when he interviews, he allows the candidates to use AI, but not in algorithm round, because in algorithm round is like 0 1 round, right? So if an algorithm question is asked from you, either there is a right answer or there is a wrong answer, right? So in those rounds it does not allow AI. But in the machine coding round, if you know about what machine coding round is, which a lot of you would know, it's like low level design round, where let's say the interviewer asks, design me low level design of a traffic light system. So that is an open ended system. It doesn't have a correct solution or wrong solution. It has trade-offs and choices that are made by you while discussing the requirements on the go with your interviewer, and then choosing the right design patterns, discarding the unnecessary requirements, creating the right interfaces. So earlier what used to happen was that when low level design used to happen, the questions used to be like this: design low level design of a traffic light system or an airline system or something like that. But now the expectation is very high. So earlier people were just, the interviewers were just comfortable with the class diagram, just create the class diagram, no need to code. But now they expect you to code it. They expect you to code the multi-threading part inside it. They expect, why? Because they allow you to use AI, and now they are like, okay, if you're good with the design, just tell that design to AI and ask it to generate the code. So these are the kind of paradigm shifts which are being seen in interviews, and this is logical. This, according to me, is not illogical, because earlier, I mean, the interview used to happen of 45 minutes, and it took you 30 minutes to think of design and discuss with interviewers only, and then the time was up. You could have barely write some class templates and all. But now if you have 20 minutes left and you are 100% clear with the design, you can generate a code. Okay, the code might not be perfect, but even if it is near perfect, if you said multi-threading and if you were able to guide the AI to generate the proper synchronized blocks or use the right thread safe data structures, that is what interviewer wants to look at. So all these things are possible because of AI, and all these expectations have risen because of AI. And this is not a bad thing. This, in fact, is a good thing when looked at from a bigger perspective, because you become more efficient, companies shift faster, startups shift faster. Uh, like the only thing over here is that you know like how to use it for which kind of use case, because that is still tricky. I mean, okay, we'll talk about that later, but let me answer some questions. uh Bang on. My fear is, what will AI leave me for? Okay. I think there'll be a lot of value to still add, I believe. It is said that some people believe and they argue that in future, everybody will be a product manager. So there will be no isolated role of software development engineer. A software development engineer will be somebody who has to have immense, depth inside the domain and an idea of customers, and then he should be able to craft the right product for them. So I think there is going to be a huge, if I talk about product managers, the opportunity for product managers is to fill the gap between their write-ups and mock-ups. So by mock-ups, I mean the functional UI or even functional backend, if it is a lightweight backend. I think with some amount of effort, like I know certain product managers who have had degree in CS, Yeah, they have had degree in CS, but they did not code for 5 years, 6 years. And now, after the advent of copilots, they were able to quickly move from their product idea, which is the write-up phase, to some sort of mock-up phase. And I believe that is a great value adding thing, because if, let's say, you have to present something to CEO or director, whoever it is that you're reporting to, presenting a slide versus presenting a demo has, I mean, tremendous difference. Because once something is demoed, then the user kind of feels that, okay, I mean, this kind of flow does not look good. Probably if you add this, that wow factor, the wow factor, personally, I have seen for myself, never comes from write-ups or PPTs or something like that. When I used ChatGPT for the first time in my life, it was something which made me wow. Although I had read about something like that before, that okay, something like that is on its way. Even I think when GPT was trying, uh, I do not remember, but it had made some announcement that something like that is cooking. So it felt great, but that wow factor only comes when product is live in front of you and you are demoing it. So I think there's a great opportunity for product managers over there in the next 2 to 3 years. How this code will help backend developer. Yeah, that is one thing which I will talk. There's a separate section where I'll talk about it. So see, there are two things. You might have heard of classical AI and AI engineering. What is the difference between classical AI and AI engineering? I'll talk about. AI engineering is something which is going to plus plus backend developer. So in earlier days, it was impossible for a backend developer to create an AI-backed system all on his own. He needed a team of ML experts, or he needed somebody from ML background to work along with him, some applied scientist or something. But now with the advent of LLMs, it is very, very possible, extremely possible for backend developers to, if you check out the page of Y Combinator, so you might have heard of Y Combinator. It seeds different startups inside it. And if you go through some startups which have been funded in last 1 year, and if you look at the people who are running those startups, you'll be surprised. That's an AI startup, but nobody has a degree in AI. Nobody uh, learned classical AI. They are regular core software engineers. Why they are able to do that? That's just because LLM made it easier for them to build an AI product. So I'll talk more about it towards the end of the class, where I have to speak about the difference between AI engineering and classical AI. Could you shed some light on how one can progressively deepen their expertise in AI with the goal of becoming an AI LLM engineer even after this course? We'll do that. We'll keep doing that. That is the entire intent. So when you look at an AI engineer is somebody who uh, kind of whispers life inside a simple chatbot. So if there is a simple chatbot, all that it does is it's like an LLM wrapper. But now it has too much deficiency inside it. It can just chat, it cannot act. If you want it to act, making it act is something which is not that trivial. You will have to add different Lego boxes inside it. So that is where different concepts like MCP, RAG, fine-tuning, small language models, all these things come into picture. And then there are certain well-defined design patterns as well, which you as an AI engineer have to use. So all those things are part of the course. Once you connect with them and once you build few things and iterate on them, then you feel like you're holding a torch, and you can discover things on your own also. And of course, we'll be having a community where we'll be uh, very, very active with these things, where you know we pick something and then we probably hold a talk or talk about it. I mean, even after the the cohort ends. All right. So now, few things which I want you guys to do is, so what you can do is you can go to this link. So just bookmark this link for now. You can go to it later on. And this is our Python course for beginners, absolute beginners. So if you have had no backgrounds in Python, then nothing to worry. This is the course. which you can quickly walk through. So even the timelines here are 5 week, 2 week, 1 week. So they are written from the perspective of a fresher kind of person, a fresher guy, or somebody who has never coded or like that. These are very liberal timelines basically. But I want you to go through module 1, 2, and 3 if you do not have a background in coding, and if you feel like you should brush up your Python. So there can be two kinds of people. First, who do not have any background in coding. If you do not have any background in coding, it's strongly recommended for you to go through module 1, 2, and 3. You can skip 4, 5, and 6 for now. Okay, just go through 1, 2, and 3. And those of you who have background in some other language and you still have that fear factor in your head that you might not be able to connect with Python, uh, which mostly won't be the case. In that case, you can go through module 1, 2, 3. So these kind of people are strongly encouraged to go through these modules because, like, when we'll be writing the code, when we'll be implementing anything, let's say a simple for loop in Python, it should not scare you just because its syntax is different. Okay, so I think it'll be a good idea if you go through it. Is Python necessary for this course? I'm currently working in Java. Okay, I'll answer this question. See, Python has the strongest and the deepest ecosystem in AI. If you look at the SDKs and libraries which are built for AI engineering purposes, you might have heard of some. You might have heard of Langsmith, you might have heard of LangChain, LangGraph, and many things like those. So I mean, when they were initially released, they were released for Python, and their Python documentation, Python ecosystem is something which is very strong. I do not know if they have their offering for other languages. Uh, that being the reason, okay, that is one example. And the example is even if you look at some, um, you know, the libraries like PyTorch, if you have heard of it. So they are like very, very native AI library, which are intentionally implemented in Python because Python provides the entire ecosystem and tools for, such development to happen very easily. So I would strongly recommend that stick to Python for the purpose of AI engineering. Initial inconvenience might be there for maybe the starting 2 weeks, 3 weeks. You might feel uh, you might have to deal with the syntax thing, but then that's totally okay. In fact, the sign of a true software engineer is somebody who does not get scared from changing languages and changing frameworks. So do not get scared about it. I mean, that's super easy. You'll be able to, if you're able to grasp the concepts, uh, maybe if not today, 1 month down the line, 2 months down the line, you will be able to code it in Python or any other language of your choice. So I would say do not have a mental model that I do not want to do Python, rather have this mental model that Python is pretty easy. I can give some time and learn it, or I can go through the code and kind of understand. Like whatever code walkthroughs I'll give you, I'll make sure that you understand what that code is. On top of that, if you want to change that code, you play around with it, which I would strongly recommend. Then getting some hands-on with Python, will be highly recommended. Yeah. All right. So, yeah. So this was about Python. Now let me tell you the flow of the course, which many of you wanted to know from the beginning. Before flow of the course, uh, I want to answer one question which a lot of you have asked. Uh, I think AI engineering and classical AI, and this is something which everyone should know. So this is a difference which everyone should know, the difference between AI engineering and classical AI. Let me, in fact, ask you a question, and based on that, I'll answer this. How many of you have ever written an API in any language? Python, Ruby on Rails, or Java? If you have ever written an API, you can just say yes. You can see almost like most of the people. I think Pratyush has never written, but that's okay. So Pratyush, API, for now, assume it's just like a remote function. So there is a function which exists on some other computer. If I have to call that function, I cannot just call it like that. I need network hops to reach to that computer and then get the response back from there. So API is kind of something like that. Okay. Now, the APIs that you have written, those APIs are actually useful because they are deployed on cloud, maybe on some Kubernetes cluster. That being the reason it is served across millions of users, and that being the reason it is useful. Yes or no? Do you agree with that? Okay. So you are the one who ship APIs. Those APIs are useful because of cloud systems like Kubernetes cluster and all. Now, those of you who have written APIs, if I ask you, how many of you really know how clusters, cloud clusters like Kubernetes clusters, actually works under the hood? Like, what is the difference between system plane and data plane in Kubernetes clusters? What are the pods? And then who takes care of the pods? Who synchronizes things? How many of you have a deep insight on these things? Again, a quick yes or no. And it's perfectly okay to say no. I mean that I know that is the natural answer. The natural answer is no. So that is what I'm saying. You are a software engineer. You create impact at your wonderful organization because of cloud without knowing cloud in depth. This is something which is called as abstraction, which is the most beautiful concept of computer science. It's abstracted out for you. You know that you have written a piece of code and that's going through a deployment pipeline that's going to be deployed somewhere on the cloud. And cloud systems are intelligent enough and careful enough to take care of the fact that the required number of instances of service are always running. 1 million users per second is always served. You just assume it that that is true. Another example is all of you have written a bubble sort function in your own ID, personal ID, right? Bubble sort function or finding maximum in an array. When you run it, what actually happens? There is something called as operating system, which takes over and acts as an interface between you and the hardware. So that actually initializes the variable at different memory blocks, probably reads from the file, loads the data in and out from cache, register, and all those things, right? Now, do you have a complete visibility on how operating system actually works under the hood? No, you do not. Still, you have probably written thousands of program on lead code or code forces here and there, right? But the very fact that they are able to run on a bare metal hardware is because of operating system. This is another example of abstraction. Similarly, LLM is an abstraction. It's okay, complete abstraction. I'm not saying complete abstraction. Like as a software engineer, you know a little bit about cloud. You know a little bit about operating system. You know a little bit about database management system. Similarly, LLMs are like an abstraction for an AI engineer. And then AI engineer can build really wonderful things on top of it. That is the role and responsibility of an AI engineer. Who is an AI scientist, or maybe call it an applied scientist or AI researcher? AI researcher is the buzzword these days. AI researcher is somebody who cracks open that model, goes inside that model, looks at the architecture, and then figures out that, okay, now let's make these architectural changes. Okay, let's probably try out with so many attention heads, these many blocks. So that guy is an AI researcher. So AI researcher is a much more niche role, and this is something which is much more generic role. If you look at how many companies are there right now who have built some consumer-based LLM. Like, can you tell me a handful count of how many such companies are there? Maybe three, four, five. How many do you think? Four to five, or maybe hardly 10 or dozen or something like that, who might be working on different, like I think Ola has a branch which is working in Indian languages, specific to Indian languages. So the idea is there are very few of them. Now, how many companies do you think are there right now who are building AI agents? Can you estimate the number? Pretty sure that is more than 10,000. For sure, more than 10,000, almost all, right? So the point is that the opportunity that lies above the stack is huge, is immense. But the opportunity that lies below the stack, which is inside the closed LLM, that first, that is very niche. Second, there are going to be very few players in that, not a lot. Okay. And it's the same thing which is there even with cloud versus SaaS products. So if you look at SaaS products, like you have Uber, Zomato, Amazon, Ola, Swiggy, all these companies, many of them, right? And then look at cloud providers. How many cloud providers are there? You have got AWS, you have got Azure, you have got GCP. So these providers, they are quite few in number. But if you look at the opportunity on the top of the stack, that is immense, that is huge. So that makes AI engineer a very viral role. That is something which has actually created this role. Otherwise, it would not have existed. Now, a very common myth over here in people's head is that, hey, AI engineering then is all about building an LLM wrapper. That is the biggest mistake. That is the biggest wrong understanding that people have. AI engineering is not about building an LLM wrapper. LLM wrapper is just uh, probably an experiment. One, you're just making a random call and changing some hyperparameters and seeing how the response changes. So that is what LLM wrapper is. AI engineering is about figuring out what exactly you need AI to do and what are the different Lego boxes or what are the different tools that you need to add to your agent in order to do that. Now, that is something which is very complex. Why that is complex is because these AI systems, they are not like software systems. They are stochastic systems. They are non-deterministic in their responses. That is the first point of difficulty. See, what I mean by that is, if there is a database in which there is a record with primary key 101, so if you do select star from where the ID is 101, you will always get the same response. Always you will get the same response, right? And no matter which part of the world you are making that call from, which device you are making that call from, which account you are making that call from, you'll get the same response, right? But when it comes to AI, you ask AI, what are your views on Indian cricket team? You ask it today, it'll say something. You ask it tomorrow, it'll say something. You ask parallelly from your mobile and computer, it says different thing because it's a probabilistic system, right? With probabilistic system, the chances of hallucination, you might have heard of AI hallucination, is extremely high. Like it might be 90% right and 10% wrong. So what I mean by that is 90% of your calls, which is 90 out of 100 calls, would be entertained with correct responses, and 10 out of 100 calls would be responded with bad responses. Now, when you're testing it on your local system, you might feel, hey, it is okay, let's ship it. But tell me, can you put a product in front of a user? Let's say you have invented an Apple iPhone for users. Let's say you're Steve Jobs. Steve Jobs, if he found out that 9 out of 10 times somebody tries to switch off the iPhone, it switches off. One time it doesn't switch off, it behaves crazy. Would he have launched it, put it in front of customers? The answer is no. So when it comes to productionizing it, it's very difficult. It's immensely difficult. That is where the depth comes in. That is where the different design patterns of building an AI system comes in. So like in software engineering, you have got different design patterns, strategy pattern, observer pattern, and all that. In AI engineering also, you have got different patterns. For example, there is a beautiful pattern, which we will talk about in one of our classes, is called as human in the loop. The idea behind human in the loop is that if AI is taking a decision, which is a high stake decision, just put that conversation trace in database for a while, send it for a human approval via an API call, let human approve it, and then resume. For example, let's say you have built an AI support engineer. Okay, what that AI support engineer does is that if there is an event in your production, let's say some sort of null pointer exception, then that automatically downloads the code base, the recent commit, and figures out that, okay, this null check was missing over here, and it uh, does a patch fix. It does a patch fix for it. Now, when it does the patch fix for it, the simplest idea is the simplest the brute force technique could be, hey, let's go ahead and deploy it. But it's risky because AI generated code, AI generated patch fix could create could probably sprinkle poison in the other flows which it might not know about. So that is where what it can do is that it can probably send a WhatsApp message to tech lead, and then tech lead, once he approves it, it resumes back the conversation and gets the job done. So like this is one design pattern. Now this design pattern exists because of the hallucinative nature of AI, right? Similarly, there are a lot of things like to make AI uh, you know presentable in front of customers, you have to tune it properly. For that, you have got idea of evals and all. Yeah, healthcare can be another great domain. So, healthcare, I mean, that's a very good example, actually, what you are giving. So, I know that I know somebody building in the domain of mental health, building an AI agent for mental health. And there, if the person who is undergoing depression or something, if that person talks general things about his mood today and all, the AI entertains. But the moment that person says that I am feeling suicidal, that is the time when it transfers the control immediately to a human or to a psychologist. So these patterns never existed, or I think rarely existed, if any, in traditional software development, because the idea of traditional software development was automate, 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 automate as much as you can. Right now, everybody wants to automate, but and everyone automated as well. But the moment people felt the heat, they saw things going haywire and crazy, these design patterns started erupting. They started kind of coming up. Another design pattern which you will get to see is what people do is that they use two different AI models, where first AI model generates the response and second AI model, it takes that response and it evaluates it and gives the evaluation result back to this if it feels that that's not good enough response. And there are certain loops of it. It runs for 3 or 4 times before coming up with the best possible response. So, and again, those of you, who have ever worked with this kind of design pattern, this is also called as generator evaluator design pattern. It has it has immense drawback. The drawback is cost, because for each request which is made, you are making multiple AI calls and there is a loop on top of that. So what I'm trying to say is it's not easy. It's not just about building an LLM wrapper. LLM wrapper means just call OpenAI API. That's it. हो गया. Then it's way beyond it. There is a lot of engineering complexity when you have to do things from the perspective of serving it in front of user, or even from the perspective of adding different capabilities to it. Like people generally think of AI agent as chatbot. No, it is not just a chatbot. Beauty happens when you make it act. When you make it act, when you make it book calendars for you, when you make it transcribe your meeting and then send you reminders, and then look up from your local file system the resumes that you have to interview. And you know, so that is where it gets amazing. That is where you would feel like coding for 10 to 12 hours a day. I mean, if you are really into building something like that. Okay. Can you list about other AI patterns similar to human? I will in the upcoming lectures where I'm supposed to do that. I will. Right now, if I do that, I'll just do that. Okay. Uh, all right. So, yeah, talking about flow of the course. The first week of the course, we'll talk about internals of LLM, like what happens when you fire a query to an LLM. Okay. So, as I told you, like as an AI engineer, you do not have to get inside the LLM, but it's good to know few things. If you know those few things, then you understand that whenever you change something in request, why does the response start to look little different? For example, temperature, there is a hyperparameter called as temperature. When you change temperature, there is a softmax computation that happens for token sampling, and that leads to I would say, less probabilistic tokens being vended out. Okay, you do not need to mind what I'm saying right now, because once I teach, it'll make much more sense. The idea is that we will crack open the model a bit and we'll see, like, okay, we'll not primarily talk about training phase, because training phase is intense and it's very different. It goes into that back propagation and deep neural networks and all. We'll primarily talk about, let's say you make a request, what are the things that happens to that request? So that request is converted into vectors. Now, what are those vectors? And then there are different embeddings like positional embedding, and then it goes through different attention blocks. And then at the end, there is token sampling, for which there are different algorithms. So there is a complete flow. These LLMs, the you know, they are very different from traditional software systems in a very strong way. That if you have used, let's say, some SaaS, let's say you're using uh, some third-party software to validate an address, to validate an Indian address. How do they charge you? They generally charge you based on number of API requests. That for each API request, we will charge you $0.0025 or whatever it is, based on per API request. But do LLMs also charge you on per API request? Do they do that? Like, have you seen the billing page of LLM? The answer is no. Why? Common sense. Because it can happen that you just made one request, but there was so much of text in that. And then you made second request in which there was very few text. So there, the billing that happens on per token basis. The more the number of tokens you have, that much computation happens, that much cost it incurs. So so there is a classic difference between the billing of this versus that. So if you look at the billing dashboard, you will instantly be able to relate to what I'm trying to say. Okay. Uh, all right. Now, how much of this course will be hands-on assignments and mini projects? It will be entirely hands-on actually. So each session is going to be hands-on. Assignments, so everything that we do in the class, I will give you the version 2 of that as assignment, which you can do on your own and you can even show it. Okay. And mini projects, they will be there. So it's basically the same thing. When you say assignments and mini projects, it's the same thing. Which, so let's say we build an AI agent that acts as an on-call support agent. Okay. Now, if I add some capabilities inside it to, let's say, do a patch fix. Now, you can just go ahead and give it a capability to scale up and scale down the system if the traffic increases or decreases. So that is how it's going to be, where you pick one thing and then you add more capabilities into it. Similarly, if you build something which is your personal AI assistant that manages your Google Calendar, I add few capabilities and then you can add few capabilities. So those are things that you can do. The number of tokens used are proportional to the number of text in the query. Yes. At the same time, I also want to tell you that number of tokens is not equal to number of words in the text. Token and word, they are different things. So again, I'll explain that in the first class, which we'll have. Okay. Yeah, so that is what we will do in the first week primarily. Second week will be about prompt engineering. And so usually when people look at prompt engineering, they feel like, why is it even called engineering? It's just about writing something, right? So when I talk about it, why, see, engineering is extensively about edge cases. Had there been no edge cases, engineering would have been something which lot many people could have done. There are extreme number of edge cases. So the moment you introduce anything in your code, you know a lot of things can go down. So you have a suite of unit tests. So you have a suite of integration tests, regression tests, which all run, and then only you approve the code changes in your pipeline, right? Prompt engineering, the best prompt engineers who I know are the ones who are extremely great at looking at edge cases. Give them a lead code problem, their first solution will be correct. On the other hand, we know a lot of people, give them a lead code question, they will be able to code it in 10 minutes, but in 10 minutes, they will make 5 submissions. So that sort of people, when I have seen them writing the prompt, it takes them 100 iterations to get the perfect prompt that does what they want. But do you see, can you relate to me on what I'm trying to say? So, so this prompt engineering thing, like if you're an engineer, you will always see through the lens of edge cases that, okay, I'm asking LLM to do this thing, but I have still missed out on this detail. If I do not mention this detail, it might be confused. At times it might do this, at times it must do that. How to become like that, like them, to learn prompt engineering, which we learn in our second week. So there are certain best practices which you can follow, and then you can ensure that you are not doing a bad job as prompt engineer. You cannot be 100% foolproof prompt engineer. No prompt is perfect prompt. I mean, there is always a scope of improvement. So how it usually happens is you write a prompt and you see that you're only getting 40% accuracy, right? Now, there is a huge difference, as I said, between traditional software and LLMs. LLMs are stochastic systems. If so let's say there is a function which sorts an array. You pass an array, it gives you an output. You can quickly check whether that output is correct or not, because you always have actual output and expected output, right? So you can match actual output and expected output, and your unit test passes or fails based on that case. And based on that, you change your code, if at all it is to be changed, change the if conditions or comparison logic, whatever it is, right? So the flow is very, very simple. But if you talk about AI systems, if there is a question like, let's say you have built an AI therapist, and there is a question that um, I recently broke up and I'm feeling like hell, something like that. Okay. There is no expected response for this, right? So you can have certain rubrics that, okay, it should be empathetic, it should be like this, it should be like that, but you cannot do that perfect object one dot equals object two. You cannot do that. You cannot compare the two objects and you can say that test pass hua or fail hua. So basically the idea is that this is called as evals. Evals, loosely speaking, I mean very loosely speaking, evals are like unit tests for AI systems, although they are way broader than unit tests because they are much, much more difficult to write. And they are the one which improves your AI engineering system. So it's 40%, you run evals. Evals tells you what to change in the prompt or what other tools to add. You add it, then it becomes 50%. Then you run eval again. Then it tells you that, okay, still this thing is missing. So it's like a flywheel which people run, industries run for months and months, months and months, and then eventually they are able to hit the right nail in the coffin. So like, so once I was talking to somebody very, very senior, who is at a director level in Geo. So he told me that they are building on something very cool, very amazing. And he told that we were able to write the code, build the prototype in first 15 days. But it took us 6 months to make the launch. Why it took us 6 months to launch? Because of evals. Like we started with 25% accuracy, and then we had to write the tests. We had to kind of figure out that, okay, we need to add an MCP server. Now you added MCP server, it introduces another hell of, uh, you know, uh, latency and hallucinations and all that. And then you do something else, and then you do something else. So that flywheel is something which makes it very, 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 very difficult. And what makes it even harder is that because these things have taken birth just 4 years, 5 years back, so there is no prescription, no text, nothing to follow. There is no rule book for it. So if you are searching for such certain rule book that, okay, this person did A, B, C, D and went E, and if you feel you'll do A, B, C, D and go to E, no, that's not necessary. Your use case might be very different, and you will have to figure out your own evals and strategize accordingly. So what I'm saying is that this entire system being stochastic requires even your mindset to be stochastic, requires an iterative mindset. So usually software engineers are anxious people. When they write a code, they want it to go to deployment as soon as possible, right? But here you have to have a lot of patience. You cannot deploy the first version till you have done maybe 50 or 60 rounds of this iteration. And that is something which is very, very, yeah. All right. Yeah. So prompt engineering will be in our second week where wherein we will also talk about few very important things like memory. So memory is a very important backbone of AI agent. So like when you talk to some person and let's say I ask you, what is your name? And then you say something. And then I ask, what does that mean? So you are able to connect to what does that mean because you have the previous context of what I asked you, right? In case of AI systems also, it is very important to have something called as conversation history and pass that conversation history so that in every API call, the LLM has context of what happened in the past so that it can figure out what to answer now. Memory is a very basic but still very, very important concept. And how to implement memory, we'll talk about it. Like when you deploy in production, there are different caveats also with memory, where people use sliding window approach, compression of previous memory. There are two kind of memories, short-term memory, long-term memory. Short-term memory is like if I'm talking to you since last 5 minutes, you remember what I have spoken in the last 5 minutes. Long-term memory is that you are my friend since childhood, and you know that I am very bad at history, okay? And you know that uh, I don't like spicy food. So this is what is called as long-term memory. So with when you talk to LLMs, when you are trying to generate perfect responses, personalized responses, of course, short-term memory is indispensable for a conversation to happen, but long-term memory also plays a crucial role. So if you have ever chatted with ChatGPT, and let's say you chat with ChatGPT every day in a new chat, today you create a new chat and you ask it a question that I'm planning to buy a new jacket. Where should I buy it from? Certain times you will get a response saying that as you are living closer to XYZ society, there is so and so shop. You can go and buy that. How does it know you are living close to so and so society? You did not mention that in the current chat window, but you mentioned that in your previous chats that you had. So all the previous chats that you have had, so you have to build a system that kind of distills the long-term useful memories that it has got to remember from it so that it can be useful in the next set of conversations or in the future to come, right? So yeah, memory, another thing that we will be talking about in the second week will be tool calling. So tool calling is I would say the most important part for building an AI agent. So that's like you cannot build an AI agent if you do not know how to do tool calling. So if you have to make AI behave in a certain way, if you have to make AI act, tool calling is what is needed. So that will be in second week. Third week will be on hands-on project. So the entire third week will be utilized. We'll probably not learn any new thing in third week, but we will just, okay, in third week, we will learn patterns, the AI engineering patterns, and we will actually write the code to build a very efficient AI agent. And then I'll even give you some sample codes to perform patch fix on. So I'll generate some code with some bugs inside it where AI responses will look crazy or stupid. And then you will have to do a patch fix. So that is how our third week will look like. Fourth week will be about MCP clients and servers. A lot of you might have heard of what MCP clients and servers are. I'm not going to talk about that right now because that's a deep concept in its own, but fourth week will be around that. Fifth week will be around RAG. So you might have heard of what RAG is, vector databases and things like indexing algorithms, semantic matching, keyword matching, chunking algorithms, and all those things. So RAG is like one big bulky topic on its own. And usually people understand that RAG is all about okay, I mean, there is a query, get some more context, pass it down. No, that is not how simple it is. It is very, 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 very complicated, and there are different layers in it. Okay, and each layer has a specific role, and to optimize each layer takes its own sort of different effort. So that is where we will zoom in on. So RAG will be the thing to zoom in on. Week 5. Week 6 will be around AI framework. So now, if you look at it from week 1 to week 5, we will be writing a lot of code, AI engineering code, but we will not be using any AI framework. Why? Because the moment you use a framework, you do not understand what is happening actually inside. So you are unable to appreciate it. Now that you have done everything on your own, you are preserving memory on your own, you are taking care of tool calls and everything that's there, prompt, system prompt, user prompt, everything on your own, then you feel like there is some boilerplate code, and if somebody else takes care of that, it'll be great. So that is when you get introduced to some framework. So what is a framework? Framework is something which makes life easy for you. That's it. Anything that you can do using Spring Boot, you can also do without using Spring Boot, right? But now just imagine how hard it will be. You will have to actually write the code to listen to the request which is coming to the socket, parse it into an HTTP request, and then do all sorts of things. And if you get into that, you will probably be doing network programming. You will not be writing the business logic which you're supposed to write, right? So the idea of framework is very simple to make you do what you have to do. You have to solve a business problem. There are some business rules. You do that. So that is exactly what LangChain, LangGraph. So we will not be covering all the frameworks because learning framework is usually boring. We'll learn one, and once we learn one, we will find the same flavor across anywhere else. So today, let's say you started with LangGraph. Tomorrow, if you use some other multi-agent framework, you will be able to relate. It's just the constructs are different, the function names are different, but effectively what it is doing is kind of the similar thing. Yeah. That will be week 6, building something using AI framework. Week 7 will be about AI evals. So something which no one wants to do. No one wants to write evals. Everyone wants to write AI agents, but no one wants to write evals. Why? Because it's a very tedious, very hard thing to do. Very, very hard thing to do. Like some very good organizations, very matured organizations also ship their product without evals, and later they realize that okay, we are not gaining traction, nobody is using it. Okay, so let's put it down, let's write evals and refine it for 6 months, and then later on. So eval is a tedious part, I would say, but something which is very, very useful to learn. Okay. The final week will be around fine tuning and stable diffusion algorithm. So stable diffusion algorithm is an algorithm behind image generation. So we will understand how image generation is backed by stable diffusion, and fine tuning. When I talk about fine tuning, fine tuning will be the part where we'll talk about how we crack open the model and change its weights, and how do we do it efficiently? How do we do it for small language model? We cannot fine tune GPT-4 because we don't have so much money to do it and so much compute to do it. But we will definitely be fine tuning Llama or Gemma or Quen, some Chinese model, or not necessarily Chinese model. It could be even Llama also. Yeah, we can do it for Llama. In fact, in the first cohort, we did it with Llama. So we learn that what fine tuning strategy, there is something called as LoRa and QLoRa. And what is that? Uh, how does it make fine tuning efficient, and what happens when you fine tune the model? So how do you probably go from 45% to 75% just by fine tuning? So that is something which is very, very important. So fine tuning is not just about, it's not just about running the fine tuning exercise, but it's immensely about generating proper data. It's a lot about data engineering. So I'll tell you one thing, like so a lot of people, they started fine-tuning a well-known AI model on all the data that they had on Slack, okay, of their organization. So it was a generational model which was supposed to act as a personal assistant, help you with crafting an email and probably crafting a write-up and all that. And they wanted to fine-tune it with all the Slack data of the entire organization, because on Slack, such kind of conversations usually happen, right? So when the fine-tuning was done, and the model was being tested, the first thing which somebody asked was, can you help me write an email to so-and-so with so-and-so body and title and whatever? The reply of the AI agent was, okay, I'll do it tomorrow. So, so what I'm trying to tell you is when you fine tune, it is very important to figure out the right data on which you should fine tune, right? If you want somebody to follow your instruction as it has been said, as it has been asked, you cannot just fine tune on Slack data, right? Because when you fine tune on Slack data, and if a lot of people are like procrastinators who say, I'll do it later, my stomach is aching and I'm not in a good mood. And if AI tells you that, you'll feel like pissed off, right? So it's very, very important to figure out the right data on which you want to kind of fine tune. So one great example of fine tune could be building an AI tutor. So if so, I was once working on an AI tutor, and I kind of found it out that finding the right data to fine tune an AI tutor on. So let's say I teach, I have taught several batches of BSA, and I have different transcripts and all also available. But the fine tuning probably is not going to be that easy because the way I teach, the kind of things I say, the times at which I take pause, and I don't want my model to learn that. So it so turned out that I was unable to do it because I did not have the right data. If I had the right data, if let's say 10 years back or 7, 8 years back, I would have known that GPT will be launched in 2022 or 23, then I would probably have taken every class like that and I would have created every transcript like that. So I would have had data, but that time is gone. So when you take data of history. And in history, you don't know that is this thing is going to come, right? So what you have is something from past, and then you have to churn it, you have to change it. Or if you are lucky, certain times you get data. So like one big caveat of fine tuning is data. Okay. And then the fine tuning itself is also a science on its own, which we'll talk about. So that is how it's going to go. Now, let's quickly tell me about the tools and environments that you need to have. How many of us have a Python IDE, or for that matter, any IDE like Visual Studio or anything installed on your laptop, on your system? Okay, so those of you who do not have, I strongly recommend you to install one IDE, and I'll strongly recommend Cursor. If you can install Cursor, I mean, Cursor has a free tier of usage also. So if you can install with Cursor, you will be able to vibe code as well. So that is something which is pushing me to ask you to use Cursor. If you're using VS Code or something which is already integrated with some Copilot, you can go ahead and do that. Okay, vibe coding. Vibe coding, it's just a term. It's all about making AI generate the code for you. Okay, so you write a prompt, so it's just like imagine you're chatting with ChatGPT. You want it to write a code of bubble sort on strings. So you say your requirements and then it generates the code for you. So you have got AI agents like built-in AI agents and Cursor through which you can generate those code. And then I like that interface. That interface is great actually. So it generates the new code, shows you the new code in green and red, and it's just like Git, like those green and red signs, and you're very clear on what has changed, what has not changed, and then you can pick and choose what you want, what you do not want. So it will be a great idea if you guys install Cursor if you don't have. Uh, uh, I think, okay, so if you go to Cursor, download, yeah, so you just need to go here. And installation is pretty easy. I think if you are on Windows, it will probably download an installer file which you will have to run. Otherwise, I think on Mac you have got a different file. I think what is that, DMG or something. So it's very simple. You just have to run the installation script or that executable file, whatever it is, and then it'll install the app for you. You can open the app, and then there is some free tier of users. That free tier should be good enough. If you feel like you are really liking it and you want to take a subscription, you can try out a subscription of it as well. Like I started using it and since then I've been liking. But if you already have a subscription of something from your company, I think if you are working with an org, lot many orgs these days provide access to such tools. Please feel free to use that also if you can. Yeah. Second thing which will be very handy, I mean, uh, in fact, very good to have, would be if you have an account on ChatGPT and if you have API access, some sort of API token. So let me show you that. In fact, if you go to this link, platform.openai.com/login, you can just log in here and you can also create an API key. All right, so this is my API keys page. So this is my API key that I created. You can just click on here, click create new secret key, and thereby you'll be able to create a new API key. So I think all of you know what API key is. It is just like you can treat it like a license, secret key, which you have to pass whenever you make an API call. Then only your request will be authenticated, and then your API requests will be served. Otherwise, they'll not be served. Another thing that you will have to do is like here, if you can put in some $5, I mean, no need to do it right away. Uh, Probably you can do it when you feel the need for it. You can recharge it with $5 so that you can actually make the API calls and play around with it. If you have friends, you can, and if they can give you their API key, you can take and use those. And if you have something which is provided by your organization, you can use that as well. But having this will make it easy for you to experiment. Otherwise, you won't be able to experiment because in the initial days, in fact, for a very long time, we will be using foundational models. Now, using foundational models, I mean, you cannot run them locally on your laptop. I mean, you have to make an API call. For that, you need an API key, right? And like I generally recommend GPT-4o because they have very friendly API interfaces. So I recommend people to use it, although it costs something, but I think $5 of recharge or something like that, whatever is minimum, that should be enough. Uh, yeah, if you can manage anything free from anywhere, feel free to do that. Okay, one thing that I can tell you is Gemini, which is Google's LLM, that is free. That is absolutely free. So you can create an API key on Gemini and you can use that also. But when you call Gemini, the API signature and response schema and all will be little different, but that's still all right. So basically, when you go back today, uh, create an OpenAI account, and if you can, recharge it with $5. Okay, or you can recharge it later on also. Do the same thing with Gemini. Okay, there is one more thing which is called as Open Router. Have you heard of it? How many of you have heard of Open Router? It's very trendy and very. So this is Open Router. This also has a free tier. This Open Router also has a free tier. Now here, uh, you can call any model of any provider. You can call Claude's model, Sonnet, you can call GPT-4o, Turbo, and it has a free tier. So that is one great thing. I think it has a good enough free tier, and you can call different models and play around with it. So this is also pretty useful. So three things, OpenAI, Gemini, and Open Router. Just create an account, and if you want, play around a bit with them if you want, or at least create API keys, and then we'll anyways be needing them in the next classes that we will be having. Apart from that, if you do not have a GitHub account, please create a GitHub account, because all the code that I will be writing, there is only one way in which I can share it with you, which is through GitHub. So I will be pushing the code on GitHub and I will be sharing the repository link with you. So if you do not have a GitHub, I think all of you might have GitHub account. So anyone, so just in case if you do not have, please create a GitHub account so that you have access to the code. You can clone that code on your system and then you can play around with it as and when you want. Last but not the least, please install Python because it will be needed. Install Python, install pip, which will be managing the package for you, pip or pip3, whatever is needed. And this much should be enough. I wanted to talk about few best practices in the course. Try to attend all the live classes, make notes, and play with the code. This is the best thing that you can follow. Attend a live class, make notes, You might not be able to code along with me because uh, it might be, it may be a little difficult to follow along and code as well. In fact, it is difficult, but when you make the notes and go back after the class and then download and see the code, it makes sense to you. So this is the best practice that I would recommend. Do not miss live classes. However, if there is something like that, some situation that you missed, make sure you watch recording as soon as possible. Okay, in most of our classes, we do a breakout room activity. So when I teach a concept, I might give you a problem based on that concept. And that problem might be an open-ended problem for which I will create different groups and I will push every group into their own breakout room. The requirement of the breakout room is that you have to keep your video on, because if you do not keep your video on, it's very hard to connect with the person sitting. Okay, so make sure that you have good internet connectivity and you're sitting at a place where you feel comfortable to turn your video on and have discussion with people, because as I said, it's a very hands-on activity, very discussion based activity. So the more you interact, the more you learn. So please ensure you do that in the breakout rooms. WhatsApp group. All of you are added on WhatsApp group? Anyone here who is still not added on WhatsApp group? So we have a WhatsApp group, by the way, in which all of you have been added. If by chance you are not added on WhatsApp group, you can just put your number here, WhatsApp number here in the chat box, and then you will be added by tomorrow or day after tomorrow, whatever. All right. And one more thing, the Python course link that I gave to you, for that you'll have to create an account on the website. So please create that account, because once you create that account, uh, the the videos, the course videos will also be pushed over there for you to have an easy access to. So make sure you create an account over there and then it'll be easier for you. Do we get any notes? We are making notes. We are transcribing all the lectures that we have had. Having said that, please make your own notes. And there is a very strong reason behind it. If you make notes, you learn at 2x the rate that you usually learn. So from my experience, I'll tell you whatever I have learned when I made notes, I was the most efficient and I was able to even finish the course when I made notes, because there's some sort of discipline, some ritual that becomes integrated with your learning journey. So I would highly recommend you to make notes. Difference between AI engineer and AI researcher. Can you share some more light on the career growth and opportunities between the two? So, okay, I think you are currently at Microsoft, right? So can you tell me roughly, just roughly, tell me how many job openings are there right now for SD roles? SD 1, 2, 3, or principal engineer. Roughly how many openings are there? Just a guess. 500, 700,000. How much? 400. Okay. And now tell me how many job openings might be there for AI scientist role or AI researcher role. Applied scientist is the word which I think Amazon and Microsoft use, 10 to 20. So do you see the ratio? The ratio is like almost 50 is to 1, 40 to 50 is to 1. So the thing over here is that if you look at the JD, the job description of applied scientists and AI researcher, the expectations usually are PhD from Cornell or MIT or such well-known universities. And then there are few roles also. But if you look at the SD profiles, the expectations are not so niche. The expectations are usually BTech, MTech, and then openings are also many. So that being the reason, the opportunity in this space is still afloat, and it will continue to be like that for upcoming at least 2 years, at least 2 to 3 years. Okay, if somebody, if you really want to transition into AI researcher role, that's a very different trajectory. So that's a trajectory where you will have to learn the classical AI, learn NLP, learn deep learning, all those things, and then get into the architectural side of it completely, which I would say might not be the best possible bet right now for an SD. The best possible bet for an SD right now could be to become, what do you call it? I mean, rock star in building AI agents and go work with companies like Glean, which you might have heard of. Now it's no longer a startup. Glean is, I think it's founded by the co-founder of, I think, Rubrik. Uh, so it's doing great in its own domain. Work with companies like, so there is a company in lot of, so what I'm trying to say is that gain a deep expertise in it and go work with such companies which are truly building a deep vertical agent from scratch. So if there's a company which is building in legal domain, getting to understand it right from bottom till top, that what are the nuances of it and how do you actually make an AI assist lawyer versus replace lawyer and see that entire thing is going to be the biggest and the most useful learning curve for an SD. Uh, yeah, so that is what you should aspire for. At the same time, I'm not saying that you might not be able to get such job, such work in Microsoft or Amazon. There might be opportunities, but the things with companies building from 0 to 1 is that you see things in flesh and blood, and then you learn a lot. So probably look for that. If you have to look for something extraordinary, look for that. Do not look for becoming an AI researcher right away because that's a long, big, huge path. And I mean, that's going to take some years for sure. And after those years, what's going to change? Nobody knows. Yeah. Is the traditional approach to backend development still relevant and useful today? Yeah, yeah, very much, very much. See, that is where if somebody has to vibe code, if you have to vibe code efficiently, you have to be first very good with traditional approach. It's like uh, initially we had manual cars and now we started having automatic cars, right? In which some part of driving is done by you and then few controls are handled automatically for you, right? But if that breaks down in the middle of the road or if something like that happens, person who knows how to handle it in manual mode will be able to, you know, uh, recover better, right? Will be able to tune it to function, will be able to tune and drive in the way that he wants. So basically, traditional knowledge will always be very useful. Like even if you are coding along with a co-pilot, you are the one who is supposed to instruct it that make three parallel calls over here instead of making three sequential calls. Do this thing synchronously and do that thing asynchronously. It's just that you are not coding it, but you know the why behind that action and you know the action in and out. So that traditional knowledge, operating systems, DBMS, computer networks, data structures, algorithms, I think they'll always be valuable until unless humans are completely replaced by AI. After the course, will we be able to apply for the AI engineer role? Yes, very much. Very much. In fact, that is what I would expect you guys to do. That is what I would see you to do. Like, once you know all the different tools and techniques that are used for building an AI agent, you can get started. And even if you do not see an opportunity right away, you can start building something small on your own. Something simple, some simple AI agent, some personal AI agent, and then you can put that in your resume, and that will give you a lot of visibility. I can say that for sure, given the virality of the role these days. Great then. I think it was amazing to see you guys here, stay back for so long. So let's connect over next week again when we'll have our first class and then kickstart our journey from there. Yeah.